As you learned in the previous unit, a mole in chemistry is not a fuzzy little animal. In fact, it is actually just a number. So 6.022 times 10 to the 23rd is Avogadro's number. Now in the video, they shortened it down to 6.02 times 10 to the 23rd, but in this class, we are going to stick with using the 6.022 value for that. Now, moles are simply a conversion factor. It's a way for us to take a lot of really little things and make it so it's tangible for our brains and we can do calculations that otherwise would be very complex. Prior to this, though, you guys have looked at molar mass and you've looked at percent composition. So before you move into the next lesson on empirical and molecular formulas, you need to know the connection between molar mass and moles. If I have a mole of hydrogen atoms, so just individual hydrogen atoms, I have 6.022 times 10 to the 23rd atoms of hydrogen. So I'm going to just write that down. Now my question would be, well, that's fine, but if I'm in lab, how am I actually going to measure that? Because I don't have anything right now that could measure in atomic mass units, and I don't have anything that can measure individual atoms. But I do have a scale that finds the mass of substances using grams. So if we think about the molar mass is the mass of any compound, any element, and in that, you'd have 6.022 times 10 to the 23rd of whatever you're working with. So if I have the molar mass of hydrogen, which we know is 1.01 grams, that's going to be 1.01 grams of hydrogen for every 1 mole of hydrogen that I have. And that 1.01 grams of hydrogen should contain 6.022 times 10 to the 23rd atoms of hydrogen. Well, what if I wanted to step that up a little bit and look at something like water? So if I have 6.022 times 10 to the 23rd molecules of water, again, we can call them molecules because they are covalently bonded together. And I would have to look at, well, what is the molar mass of that? So I would have to do 1.01 times 2 for my hydrogen, plus I know that oxygen is 16.00. And again, where I'm getting those numbers from is that molar mass sheet that you guys were given. So that gives me a molar mass for water of 18.02 grams of water for every 1 mole of water that I have. And again, 1 mole of water will contain 6.022 times 10 to the 23rd molecules of water. Now I could use percent composition and I could figure out what percentage of that mass is hydrogen or what percentage of that mass is oxygen. So I could go back to previous lessons and do that. But right now we're just focusing in on what this conversion is. So the nice thing about knowing molar mass is if you know molar mass, the units are grams per mole. And you've already learned this and you've already been working on this. So molar mass equals grams over moles. And it's always going to be something that you can use as a conversion factor. We're going to go through empirical and molecular formulas next. And then we're going to come back to this concept of using a mole as a conversion factor where we can determine how many molecules that we have, how many atoms we have, what the mass would be, what the volume of something would be. So we will come back and use this as the conversion factor it's intended to be used for. The setting it up for the next lesson, though, you need to be able to take that molar mass and you're going to be given a starting percentage or given a starting mass of a substance. For example, if I had 24.50 grams of water, and the question might be, how many moles of water is that? because this is something that I can always compare moles of water to moles of another compound or an atom. So moles are something that we can relate to other things because there's the same number of things in a mole, regardless of what substance you're working with, right? If I have a mole of water, I have 6.022 times 10 to the 23rd molecules of water. If I have a mole of sodium chloride, I have 6.022 times 10 to the 23rd compounds of sodium chloride. So I can relate it that way. I can't relate mass to mass the same way because a mole of water is not going to have the same mass as a mole of table salt. So to answer this question, it's actually really simple. We're going to take that 24.50 grams and in prepping you for stoic, this is just going to show you the way that we do it in stoic, and then I'll show you the other way, which is the way most of you will use it. I'm going to take my molar mass conversion up here, right? I've got it right there. And I want my units of grams of water to cancel out. So I'm going to take that 18.02 and I'm going to put that on the bottom. And I'm going to write my 1 mole of H2O on the top. And so hopefully what you'll see here is that my grams of water, because if they're, it's simple kind of algebra stuff, but if you have units on the top of a fraction and units on the bottom of the fraction, they're the same, they end up canceling out. And then what's left over are my actual units. So I have moles of H2O. So all I have to do is take 24.50 divided by 18.02, and I get an answer of 1.3596, but I only have 4 sig figs, so I'll do 1.360 moles of water. So really all you're doing, if you're given the mass of something, all you're really doing is going to figure out, first of all, figure out what the molar mass of the substance is that you're working with. And if you take what you're given divided by the molar mass, you'll get how many moles of a substance you have. And from there, you can really do a lot of comparison. So everything we're going to be doing at the start of this unit is really just prepping you to do the more complicated and last requirement for chemistry, which is stoichiometry. And these things that I'm setting up here, just kind of these equivalency factors, we're just going to do one after another, after another, after another in kind of a long chain to get our final answer. So it becomes easier as we kind of go through and as you kind of see these conversion factors for what they're for. All right, I just wanted to clarify what a mole is and how that's going to relate into your next lesson. You will have lots and lots and lots of practice after working with empirical and molecular formulas. You guys are going to have lots of practice doing these conversions and you get super good out of them.